Imagine a perfect, living, breathing virtual clone of yourself that calculates your future before you even experience it. For decades, engineers and scientists have relied on computer models to test ideas, but traditional simulations share a critical limitation. They are entirely static. They exist as frozen what-if snapshots of a system, locked at a single point in time based on fixed inputs. Physical environments, however, are constantly changing. A piece of heavy machinery on a factory floor is subjected to continuous variables, daily wear and tear, friction, and sudden temperature spikes. To accurately predict how a system will behave over its lifespan, engineers realized they had to stop building isolated simulations. They needed to establish a living, continuous connection between their digital models and the physical world. This diagram illustrates the bidirectional data thread, the essential communication framework of a digital twin. As the physical asset operates, its state changes are transmitted instantly to the virtual model. The model processes this data to trigger prescriptive actions back in the physical world. Because this loop of information never stops, the digital model stays perfectly synchronized with reality. It leaves the realm of 3D modeling and becomes an actual functioning twin. We can trace the origin of this concept back to the 1960s. Long before modern computing, organizations like NASA required a method for managing highly complex remote assets that human hands couldn't easily reach. During the Apollo 13 mission, when the spacecraft suffered a catastrophic malfunction 200,000 miles away, NASA relied on a completely duplicated physical system on Earth. They used this hardware to mirror the exact conditions of the damaged vessel in orbit. Flight controllers tested various life support configurations and power-up procedures on the grounded duplicate. This allowed them to verify which operational decisions were safe before transmitting those instructions to the stranded astronauts. While NASA successfully proved the concept of twinning, creating a truly digital twin required technological infrastructure that didn't exist yet. The process would rely on manual updates until the invention of automated, high-speed data networks. Here we see an immense industrial turbine rotor. To understand how the modern architecture of a digital twin operates, we look first at the physical asset itself. The asset is wired with a network of Internet of Things, or IoT, sensors. These devices actively monitor the environment, capturing real-time operational data like friction levels, internal temperature, and vibration. This maps the resulting data flow. Raw information travels from the sensing layer, through a network layer, into cloud platforms. At the data processing layer, AI and mathematical models interpret these data points to precisely forecast the system's future states. Through this relentless process of data assimilation, the virtual twin actually ages, degrades, and experiences wear at the exact same rate as the physical asset. This flowchart shows engineers mapping this technology onto biology to create a digital patient twin. Real-world data continuously updates the mechanical model. Physicians use this replica to test treatments virtually, observing how the digital heart responds with zero risk to the actual human. The architecture scales well beyond single organs or single machines. Urban planners are now actively mapping entire metropolitan infrastructures, allowing them to accurately predict traffic flow constraints and the destructive paths of coastal storm surges. By accurately predicting outcomes within a perfectly mirrored virtual reality, we eliminate the severe financial and human costs of trial and error in the real world. This 3D simulation showcases asset lifecycle management. In smart factories, AI monitors an interconnected robotic ecosystem in real time. Through these operation panels, facility managers shift to prescriptive maintenance, predicting and resolving mechanical failures weeks before they happen. The bridge connecting the physical and virtual worlds is finally built, allowing humanity to shape its future before it occurs. If you found this breakdown helpful, please like this video and subscribe to What is Defined for more deep dives into the